All right, let's look at your Chapter 10 sample test. For problems 1 through 2, they ask us to determine whether each expression is a polynomial, find its degree, determine if it's a monomial, binomial, or trinomial, and find the leading coefficient. So first thing that I want to do is I want to put this in standard form. So remember that standard form is in descending power order. So we start with the highest exponent. So b to the third, and then b to the first, and then b to the 0. So when it's just a constant, remember that the power there is 0. So determining if this is a polynomial, remember that a polynomial is a sum or difference of monomials. And monomials are just constants or variables, or constants and variables combined. So yes, this is a polynomial. And then the degree of the polynomial is going to be the highest powered monomial. So this monomial has a degree of 3, this monomial has a degree of 1, and this monomial has a degree of 0. So the highest power would be 3. And then it has 1, 2, 3 monomials, 3 terms, and so that's going to be a trinomial. And the leading coefficient is the number out in front of the monomial that has the highest power or the highest degree. And so when we put that in descending power order, it will be the number that's in the lead, the number that's out in front. So our leading coefficient would be 2. All right, then look at the next one. So for the next one, again, I'm going to start off by putting this in standard form so that it's a little easier to see. Again, we talked about what a polynomial was a moment ago, and this does meet those qualifications. And then determining its degree. So this is x to the first, and this is y to the first. So the degree of this monomial would be 1 plus 1, or 2. And then this is 7x to the 0. And so its degree would be 0. So the degree of the polynomial is just the highest degree of the monomial, and so that would be the 2. Then it's a binomial because we have 2 terms. So monomial 1 term, binomial 2 terms, trinomial 3 terms. And then the leading coefficient is going to be the negative 6. Be sure you keep that negative with the 6. So again, the number in front of the term that had the highest degree. All right, so then for 3 through 5, we want to simplify, and we want to give our answer in standard form. So simplify meaning there are no more like terms that can be combined, and standard form meaning it's in descending power order. So when we're adding, this addition sign is not going to change anything that comes after it. So we can go ahead and get rid of our parentheses. So all we've done here is just recopy this without the parentheses. And now let's combine our like terms. So what's a like term with 2a squared? That would be negative 5a squared. So 2 minus 5 is going to give me negative 3. And then we keep the variable and the exponent exactly as they are, a squared. What's a like term with negative 3a? That would be a positive 8a. So we're going to combine a negative 3 and a positive 8 when my signs are different. I find the difference between them. So one was positive, one was negative. So I found the difference between 3 and 8. That was 5. And I keep the sign of the larger number. 8 was larger and it was positive. And then remember that our variable and its exponent stay the same. All right. And then we're going to combine the 7 and 4 and get 11. Now, when we get to number 4, notice it's telling me to subtract. Now, subtraction is different because when I subtract, it's going to change the sign of everything that comes after it. You can think of this as like a negative 1 right here that's being distributed. So negative 1 times 4 would be a negative 4. Negative 1 times negative 5a would be a positive 5a squared. And then negative 1 times positive 8a would be a negative 8a. Some of you also say keep, change, change. So that would mean that you're changing this to addition, and then you're changing every one of these signs. So negative 4, positive 5a squared, negative 8a. And that's what you'll see right down here. Okay, so now we're ready to combine like terms again. So a like term with 2a squared would be 5a squared. So 2 plus 5 is 7. We keep the variable and the exponent the same. And then negative 3a and negative 8a, negative 3 and negative 8 is negative 11. Keep the variable and the exponent a the same. And then 7 minus 4 would give us 3. All right, for number 5, we're going to do some distributing and some subtracting. So first off, let's go through and let's simplify here. I'm going to take 3c times 4c cubed. So 3 times 4 is 12, and c times c to the third. When your bases are the same and you're multiplying, you add your exponents. So this was c to the first times c to the third. 1 plus 3 gave us c to the fourth. Then 3 times negative 6 is negative 18. C times c would be c squared. So again, c to the first times c to the first. 1 plus 1 would be 2. And then negative 5 times 2 would be negative 10, c to the third. And negative 5 times negative 8 would be positive 40. I don't have any like terms that I can combine here, but I do need to put this in descending power order in order for it to be in standard form. And so that's what we've done, c to the fourth, c to the third, c to the second, and then no c. Then for number 6, our instructions told us to solve. All right, so for this one, it told us to solve for n. So I'm going to try and get n by itself. So first off, let's come over here and simplify. So we're going to distribute. So we're going to say 5 times 2n is 10n, and 5 times negative 4 is negative 20. Now I want to get all of my variables on one side and all my numbers on the other. So I'm going to get rid of this positive 7n right here. So I'm going to use the inverse to do that. So I'm going to subtract 7n from both sides. So 10n minus 7n gives me 3n, and 7n minus 7n gives me 0. So that dropped out. All right, now I want to get all my numbers over here on this side, so I want to get rid of the subtracting 20, so I'm going to use the inverse of that. I'm going to do adding 20, so I'm going to add 20 to both sides. So over here I'm left with 3n, negative 20 and positive 20 cancels out to be 0, so I just have 3n plus 0, or 3n, and then negative 11 plus 20 would give me positive 9. Divide both sides by 3, and we'll have n is equal to 3. Now, remember that with an equation, when you're solving, you can always go back and check and know for sure whether you got your answer right before you turn your test in. So I'm going to take that 3 and I'm going to put it right back in the place of n here and n here. So that's what we did right over here. 5 times 2 plus n, we put 3 in for that, minus 4, is equal to 7 times n with 3 in for that, minus 11. So order of operations over here, I would do 2 times 3 is 6 minus 4. And 6 minus 4 would give me 2, and then I could do 5 times 2 and get 10. Over here on my right-hand side, again, order of operations, 7 times 3 is going to be 21, and 21 minus 11 is equal to 10. So I got an identity, I got a true statement, so that means that that solution works. It checked. Now, if I had gotten down here and had something like 10 equals 5, then I know that I have a problem. So I need to go back and check to make sure that my solution is right or that my check is right. All right, then for 7 through 12, the instructions will say multiply, give answers in simplified standard form. So again, simplified meaning no like terms or anything like that can be combined any further, and standard form in descending power order. So when we have a binomial times a binomial, we're going to FOIL. So I'm going to say first, d times d is d squared. Outer, d times negative 4 is negative 4d. Inner, 5 times d is 5d. And last, 5 times negative 4 is negative 20. Frequently, our inner and outer terms will combine, and so you'll notice here they are like terms. So a negative 4 and a positive 5 would give me a positive 1d. All right, look at number 8. So same idea, I'm going to FOIL. So first, j times 3j is 3j squared. J times negative 6 for the outer would be negative 6j. Negative 5 times 3j for the inner would be negative 15j. And then negative 5 times negative 6 would be positive 30 for the last. So our outer and inner are like terms that will combine. So negative 6 and negative 15 gives me negative 21j. And again, that is in descending power order, so that is in standard form. All right, then for this next one, first, 7f times 4f. So 7 times 4 is 28, and f times f is f squared. And then outer, 7f times 2 would give me 14f. Inner, negative 5 times 4 is negative 20 times f, so negative 20f. And then negative 5 times 2 for last would be negative 10. positive 14f and the negative 20f are like terms, so we can combine those, and that would give us a negative 6f, and again, that is in standard form. All right, so for number 10, I've got 3k minus 5 squared. Please remember that means 3k minus 5 times 3k minus 5. Go ahead and write it out that way, and remember that you have to FOIL. So I'm going to do 3k times 3k, so 3 times 3 is 9, and k times k is k squared. Then I'm going to do 3k times negative 5, so that'd be a negative 15k. Negative 5 times 3k would be negative 15k, and negative 5 times negative 5 is positive 25. Our negative 15k and negative 15k will combine as like terms to be negative 30k. The most common mistake I see with this is that students square this first term and get 9k squared, and they square this last term and get 25. So they get this part and this part, but they're missing the inner and the outer terms that combine. So that would be half wrong. So we want to be sure that we rewrite that as the binomial times the binomial and FOIL it out. All right, number 11 is a difference of squares. We see that when we FOIL it together. So when we have the exact same terms, but one sign plus and one sign minus, we end up with a difference of squares. So if we FOIL, 9 times 9 is 81, m times m is m squared, and then 9 times negative 6 is negative 54 times m. 6 times 9 is positive 54 times m, and then positive 6 times negative 6 is negative 36. So the positive 54m and the negative 54m are going to drop each other out, and when I combine them, and that leaves me with just 81m squared minus 36. So again, 81m squared is a perfect square. That would be 9m squared, and 36 is a perfect square. That would be 6 squared. So it's the difference of 2 squares. All right, then look at number 12. So for number 12, here's another one like we talked about with number 10. It's really important that I rewrite it as that binomial times itself and that I FOIL it out. So we're going to do 2g times 2g is 4g squared. 2g times 10h, so 2 times 10 is 20, and then g times h is gh. 10 times 2 is 20, g times h is gh, and then 10 times 10 is 100, h times h is h squared. So these inner and outer terms will combine, so 20 and 20 would give me 40 gh. All right, then for number 13, they asked us for 13 through this next section, they asked us to factor completely. All right, so the very first step in factoring is always going to be to take out our greatest common factor. So let's start with 12, 20, and 16. Greatest common factor is the largest number that will divide into all three numbers. So if you can look at that and see the largest number that will divide into 12, 20, and 16 is 4, fantastic. If not, then we can come up here and we can make our factor trees. So we could say that 12 is even, so we know it's divisible by 2, so that would be 2 times 6. And 6 is even, so it's divisible by 2, that'd be 2 times 3. So if we have 12 r squared s cubed, the 12 was 2 times 2 times 3, and then r squared, r times r, s cubed, s times s times s. All right, then for 20, it's even, so it's divisible by 2, so we can say 2 times 10. And then 10 is 2 times 5, so you can see that's going to give us 2 times 2 times 5. And then r cubed would be r times r, and then times s. And then for 16, we know that's even, so that's going to be 2 times 8, and 8 will be 2 times 4, and 4 will be 2 times 2. So that's going to give us 2, 2, 2, 2. So 2, 2, 2, 2, and then we had r squared, so r times r, and we had s squared, so s times s. So we're going to keep only what they have in common. So you can see they all have a 2, they all have another 2, they all have an r, they all have another r, and they all have an s. So my greatest common factor is going to be 2 times 2 times r times r times s, or 4r squared s. All right, so let's take that out. Now, when you take out a factor, there are two ways that you can find your other factor. You can either multiply or divide. So let's look at it both ways, because one of those is going to feel more comfortable to you than the other. So we could say 4 times what is 12,